So I'm going to walk through the use of the PhET circuit construction kit just to show you how it works and to walk you through the worksheet in case the PhET simulation is not working on your computer. So at the left, we have a toolbar and we can drag in various elements of a circuit. That brown line represents a wire, probably made out of copper. This looks like a battery. Here I've got a light bulb. You can see that when you bring the dotted circular ends together, that connects the different elements of the circuit just without you doing anything. So now this wire is linked to that light bulb, and now it's linked to the battery. I'm also going to add a switch, and let's go ahead and complete the circuit here by connecting those wires. It's kind of nice when it's shaped like a box, but you can make it any shape. And you could have used less wires than this to build your circuit, but this looks nice. So we know right now that we've got an open circuit because the switch is open. And if we have an open circuit, then the electric current won't flow. But if we do connect our power supply to our wires and to our load, which in this case is this light bulb, then we've created a continuous closed circuit that the electrons and the current can now flow around. So when I click on the switch, it's going to close the switch. It says that at the bottom, the switch is closed. And that you can now see that these little negatively charged circles, these little electrons, are moving around the loop and making the light bulb light up. So we've successfully made a closed circuit, and we've got electric current flowing. Now, if I want to do some changes, if I open the circuit, obviously it stops. If I want to see what it means for conventional current, we talked about how briefly that conventional current actually represents the flow of positive charges. So at the time that electricity was being initially studied, they didn't actually know about the existence of electrons. And so although now we know that the particles flowing when electricity is flowing through conductors are electrons, these negatively charged particles that atoms have and that are fairly free to move in metals and other conductors. At the time, they didn't know that, and so they actually always referred to the flow of electricity in terms of a positive charge that's flowing. So you can see that instead of representing it as particles, the simulation just represents it as arrows, saying that that's the direction in which the charge is flowing. And you can also see that it moves in the opposite direction from the electrons. So in the end, it doesn't really matter. The idea about what current is that current is the flow of charges in a wire or through a circuit. And it doesn't really change anything except the direction if we think of it as negative charges flowing or positive charges flowing. It's really, it's not going to affect any of our calculations or any of the other ideas that we have about electricity. Now, this is sort of a cartoon image of a circuit. This is a little bit closer to a circuit diagram. So I'm going to open the switch so you can see it a little better. In a circuit diagram, we represent wires as lines. We tend to draw dots where they join, but sometimes we don't. We just draw the lines connecting. Down here is an image. This is the battery. The two different sized lines are the batteries, where the longer line represents the positive end of the battery, the positive terminal, and the shorter line represents the negative terminal. You'll notice when we close the switch again that the positive current comes out of the positive end. And if I click on electrons, the negative electrons come out of the negative end. This is a switch, so you're showing where in the diagram that this part of the circuit can open. And this is how you would draw a switch on any circuit diagram. Even if you then want to talk about it when it's closed, you still draw it as an open switch because you can't see it when it's drawn as a closed switch. It just looks like part of the circuit. So we always draw it like that. And then this is one way to draw a light bulb. It's this circle with this sort of other little design on the inside, this other little semicircle. A simpler way to draw that, which is also acceptable, is a circle with an X through it. That will also be another way to represent a light bulb. Okay, so now I'm closing my circuit. So that's a circuit diagram, and we'll mainly draw circuit diagrams or give you circuit diagrams to interpret because eventually drawing things like cartoony like this, not everyone's an artist and it doesn't work as well when we're talking about different scientific concepts. So we're going to use circuit diagrams more often. So far we've got an open and closed circuit, and we understand that the difference between conventional and regular current And really, usually when we talk about current, we're talking about conventional current. It's just talking about negative charges flowing versus positive charges flowing. Now, I'm going to pull in a device onto the simulator that's called an ammeter. And that's because it measures amps, or the unit amps or amperes. And now you see that when I pull it in, instead of saying ammeter, it says current. So an ammeter is a device that measures the current. And the current is the flow of charges through the circuit. So the current is the rate at which electric charges are flowing through the circuit. Now, it's a little more complicated than this, but this is just a nice way for the simulator to keep it simple. So I can see that if I move the meter over the wire, it tells me that the current flowing in this circuit is 0.9 A. And A, that capital A, stands for the unit ampere or amps. So that's the unit that we're going to use for current. And I'm going to talk about what that means in a subsequent lesson. And you can see that the current on this part of the circuit is the same as the current on this part of the circuit. It's the same there, it's the same there. So the current in one loop of a wire, of a closed circuit, the current is the same at every single point in that wire, in that circuit, sorry. And it doesn't matter if I think about it as electrons or as positive charges, the current is the same no matter where I am in that circuit. Now, when I click on this battery, the battery is my power supply. The battery is the thing that's giving energy to these electrons. It's what's pushing the current around the loop. It's what's giving energy to the light bulb, to light. And I can see that if I increase the voltage, I can drag it, or I can use this arrow. I've increased it to 10 volts. And I don't know if you noticed, but it made the current increase. And if I increase it some more, the more I increase the voltage, the more I increase the current. So there's a relationship between the voltage of your battery, the voltage of your power supply, and how much current you're going to get flowing in a given closed circuit. So greater voltage leads to greater current. I don't know if you noticed, but there's also something that happens to the light bulb. As I decrease the voltage, I get less current, and I get a lot less light coming out of the light bulb. And as I increase, I get a much, much brighter light, and I get much, much faster current. So there's definitely a relationship between voltage and current, which seems to be that as one increases, the other increases. We're going to look at the quantitative relationship down the road. But as voltage increases, so does current in a given circuit. Also, I would say as the light glows brighter, it's clearly giving out more energy, giving out more light energy. So there's also a clear link between voltage of your power supply and the amount of energy of your electricity. So voltage is very closely related to energy of our electricity. Current is the flow or the rate at which charges are flowing in the circuit. And those are kind of the basic principles behind circuits and some of the first terms that we're going to start using when we talk about electricity. So voltage is related to the energy of the electricity, and current is related to the rate at which electric charges are flowing through a circuit.